Hello. In this video, I will be talking about test of a single variance. In other words, we will do hypothesis tests for sigma squared or sigma. So this is the variance and this is the standard deviation of the population. They actually go together well since the standard deviation is the square root of the variance. Recall that the sampling distribution for the sample variance is S squared, this is the notation for the sample variance, is a chi-square distribution. So in this chapter, we talked about chi-square distributions in the previous video. So you know what the chi-square distribution is, how it looks like. And recall that the degrees of freedom for this distribution is the sample size minus 1. To test claims about variance or standard deviation, we will use a chi-square test. Assumptions for chi-square test for single variance. The sample must be randomly selected from the population. The population must be normally distributed for the variable under study, and the observations must be independent of each other. Let's see how the test statistic looks like. The test statistic for the given test is given by this formula. And hopefully, when you see this formula, you know that you've seen this before. And this is the same formula we actually used for creating confidence intervals for variance or standard deviation. N is the sample size. Degrees of freedom will be n minus 1. S squared is the sample variance, and sigma squared is the population variance. We will do this type of test using formulas. We do not have a command on the calculator. So we will simply do this using the critical value region or even the p-value. We will find all of those values using the formula and applying the commands that we know. So in order to reject h sub 0 using the critical region method, we will follow the same procedure as before. If the test statistic is greater than the chi-square to the right for a right tail test, that means that the test statistic falls in a critical region. And that's why we will reject the null hypothesis. Now, if we are dealing with a left tail test, we look for rejecting the null hypothesis if chi-square falls in a critical region. And the critical region this time will be to the left, which means chi-square, the test statistic, will be less than chi-square to the left. For a two-tailed test, we will reject h sub 0 if either the test statistic is to the right of the chi-square to the right or to the left of the chi-square to the left. Just keep in mind, the critical value corresponds to alpha over 2. Level of significance should be split in 2 for a two-tailed test. So let's go over some examples. Here is our first example. A statistician believes that the standard deviation of the weights of firemen is less than 25 pounds. To test the claim, he selects a sample of 20 firemen and finds that the standard deviation is 23.2 pounds. Assume that the weights are normally distributed as the claim using alpha equals 0.05. So we have the given information, which is not a lot. We are doing a test for the standard deviation. So what's given is standard deviation is believed to be less than 25 pounds. And this is the claim. So he selects a sample that will be a sample n equals 20. And he finds that from the sample, S will be 23.2 pounds. That's sufficient to answer the question or test his claim. So we are asked to test the claim, which is that sigma is less than 25 pounds. So we are testing standard deviation sigma. Let's go ahead and set up the hypothesis. And let's try to do this first using the critical region method or traditional method. Step 1, set up the hypothesis h sub 0, h sub a. So we look at what we have given and we see this strict inequality related to the standard deviation. So that will become alternative hypothesis. Sigma is less than 25 pounds and the null hypothesis will become sigma greater than or equal to 25 pounds. Also, the alternative is the claim And we see that we are doing a left tilt test. Step 2, the distribution we are using is the chi-square distribution. So when we work with sigma or sigma squared, we always use the chi-square distribution. The chi-square distribution is a family of curves, so we need to write down degrees of freedom. Degrees of freedom in this case will be 20 minus 1, which is 19. And there is no calculator test that will do this one. At step 3, and make sure right here we will write down alpha. Alpha is 0.05. And somehow I didn't put it here, so I'll put it under the given information. Now, to find the critical values, we take alpha, which is 0.05, and we will find chi-square. And because this is a left tilt test, we need chi-square to the left, okay? So let's try to find that value. In order to find the value, first, I would sketch the graph. This is the chi-square distribution. This is skewed to the right. Degrees of freedom, 19. And I'm looking for chi-squared to the left, since this is a left tilt test. So the entire area right here on the left will be 0.05. So I want to make sure I know that alpha is actually right here. And I'm looking for this value, which will be chi-squared to the left. And I'm looking in the chart for that value. So let's pull up the chart. I'll try to have the chart here and inspect the chart without clearing the screen, which proves challenging at times, but I think we got it. And keep in mind, we are looking for degrees of freedom 19. So based on what I have here, the area to the right will be 0.95. And I will add an extra 0 because that's how it looks like in here. So the area to the right for my problem, this one, because this is what it is on the table, is 0.950, since I have 0.05 right here on the left. So chi-square, which has 0.95 to the right, is this one. And 19 will be right here. So the intersection of those two will give me 10.117 as the chi-squared to the left. So make sure we have this right. So this will be 10.117. So I hope this makes sense. Check this again. Make sure you understand how we got this value. This value is the intersection of the chi-square that has 0.95 or 0.950, right, to the right, and 0.05 to the left. Now that we have that value, we want to find the test statistic. So to find the test statistic, we will simply use the formula. And I will make some room right here to do the work. So chi-square is n minus 1 times s squared divided by sigma squared. This is the test statistic or the standardized test value. So we will simply find the test statistic by plugging in this formula. So the test statistic will be 20 minus 1 times s. S is right here. We will need to square it. So 23.2 squared divided by sigma squared, which is 25 squared. So do the calculations and let's see what we get. So after you did the calculation, you should have gotten 16.36. This is the test value or the test statistic. So I'll write it down right here below the critical value. This is chi-square, which is 16.36. I will use this and the visual right here to conclude the test. So I will simply say the critical region is the one that's far away, is to the left, corresponding to the area in the tail, which is corresponding to alpha. This is critical, while non-critical will be here on the other side, non-critical region. Let's take this test value and see where it falls compared to the critical value. The critical value, and I'll put the value right there, is 10.117. So it is clear to us that 16 is actually larger than 10. So it will fall in a non-critical region. And because of that, we will not reject the null hypothesis. we will fail to reject the null hypothesis. So let's write the conclusion right here, and then we will interpret the results. So I will simply say fail to reject H sub 0, or, I use the acronym fail to reject H sub 0. And I'll explain why. Because chi squared is greater than chi squared to the left, and this is a left tail test. 5, we will simply state that at alpha equal 0.05, they are blank enough evidence to blank the claim that the weight of firemen is less than 25 pounds. So you may want to stop the video and plug that in, then check back, or let's see, fail to reject H sub 0. You are not crossing this out, which means you do not have enough evidence to support this. Well, along with this, the claim is not supported. So we will say there is not, because we start with fail. When you start with fail, you say is not enough evidence to, are we supporting or rejecting the claim? We do not have enough evidence to support the claim. And with this, we've done our first test for a single population standard deviation. We will do one more example, but this time we will be using the p-value method. Assume that the height of adult males in a certain region are normally distributed. The heights in inches of 20 randomly selected adult males from this region are listed below. Use the sample data and a 0.05 significance level to test the claim that the variance of all heights in this region is less than 6.25. So here we have the given information. Well, the random variable is height in inches of males, and we have a sample of 20 data values, and we have raw data right here. We know we have to test this at 0.05 level of significance. And what we need to test? We need to test the claim that the variances of all heights is less than 6.25. Be very careful with the notations here. This time is the variance, is not the standard deviation, so we have to use sigma squared, and we have to test that this is less than 6.25, okay? And I'll just write down test for sigma squared. This is the claim. So in order to do the test, I will write down the hypothesis, H sub 0, H sub A, and as I said before, we will do this using the p-value method this time. But again, we have to go through the formulas because there is no function on the calculator that will do the whole test. H sub 0. H sub 0 will be sigma squared is greater than or equal to 6.25, since we see right here in this box, this is strict inequality. So this one will actually become the alternative hypothesis. So you first write down the alternative hypothesis, and then in this case, of course, you will switch the sign and make sure you put in the equal. So that will be how you write down or you state the hypothesis. The claim is H sub A. And again, this is a left tail test. Step 2, we are testing the variance. So we'll be using the chi-square distribution. We have to state the degrees of freedom. Degrees of freedom, 20 minus 1, so it is 19. And we do not have a calculator command for this, okay? Step 3, find the test statistic, chi-square test statistic. How do we find it? Well, as simple as plug in the formula, which is not complicated at all. So plugging in the formula, we have 19 times s squared divided by sigma squared. Well, I know sigma, but it seems that we run into a situation. And again, pay attention to notation. Sigma squared is 6.25, so I don't have to square it, okay? But it seems that I ran into a situation where I am wondering what is S, and then I will square S. The information is not among the given information right here, but we have raw data. So what we need to do, a little bit more work, we need to put it on the calculator and find S. So at this point, take the calculator and find S, because we need S for this problem. Now, how do we find S? First of all, we go to stats and we edit. We have to enter the information in one list. I already did that. You may want to stop the video and put the information in a list. You have 20 values to put it in list 1. And then I'll go to stats and I'll be looking at one variable stats. One variable stats for list 1. I need to calculate, and the only information that I actually need from here is S. So make sure you know where to find S, especially if you have raw data. Don't forget about the one variable stats that gives you all the information and just pick the ones that you need. This is the S. If you wanna carry more decimals, your answer will be more accurate. I will carry 2 decimals for S just to be consistent with sigma squared. So I will simply plug in, and of course I will estimate then 19 times 1.73 squared divided by 6.25. So keep in mind, this is S, you need to square it. This is sigma squared. You don't need to square that because it's already squared. So let's use the calculator to actually do that. 19 times 1.73 squared, and that should be divided by 6.25. And this is what we got. Chi-square is actually 9.098, and this is the test statistic. Now we need to find the p-value. In order to find the p-value, think about what the p-value is. The p-value is actually the area in the left tail. So here we have our chi-square distribution, and the degrees of freedom we use here are 19. And we have the test value, which is 9.098. This is a left-tailed test, so I will shade this area. This is actually the p-value. How do we find the p-value? Well, the p-value can be found by using a function under the distributions. And that function is chi-square CDF. We have to state from where, which will be 0, to where, which will be 9.098, and degrees of freedom, 19. So this is very similar to normal CDF or TCDF. We have this on the calculator, so we will use it. Just go to second bars, and you will see the chi-square CDF, option 8. So chi-square CDF from 0 to 9.098, and we have to state the degrees of freedom. In our situation, we have 19. And then we will have the area under the curve. And the area under the curve, it's 0.0282, rounded to 2 decimal places. So this is the way to find the p-value. Just make sure you make the connection of how the test value is related to the p-value. The test value is the value on the axis. The p-value is the corresponding area under the curve. So for the p-value here, we found 0.0282, round to 2 decimal places. So this is an area. I'll just keep it to 2 decimal places. This is a test value, the chi-square. I kept it to more decimal places. Usually we keep it to 2, but I want it to be more accurate a little bit here. Hope this makes sense. So p-value was found, and now we will be able to conclude this test using the p-value method. Here we go. We know using the p-value method, we have to compare p-value with alpha. So I have 0.0282 and alpha, which is 0.05. So comparing these two values, 282 is less than 500, just ignoring the 2 zeros before. So we see that we need to reject H sub 0. Or as an acronym, I use RH sub 0. So step 5, we will say again at alpha equals 0.05, level of significance. And I'm going through the process again. Just make sure you know how to fill in the blanks and what makes sense. And this time I will let you copy all of this down. The claim that the variance of all heights in this region is 6.25. I'll just put the symbols in here that it should be stated in words. So again, I'm rejecting H sub 0, which means I do not have enough evidence to support it, which means I have enough evidence to support the claim. So we will say there is enough evidence to support that claim. I hope this makes sense. Thanks for watching, and this concludes the video.